Okay, welcome back. We are doing, they always have something to do on my house. Somebody found out I have money, and now there is construction at my house on a daily basis. If you ever have money, don't tell anybody, because they'll come out in droves and try to figure out what's wrong with your house. And oh no, you need to fix this, you need to fix that. And I can do it for this amount. I'll help you out. I'll do it for that. Anyways, quadratic functions, graphs, quadratics, um, two basic orientations, this upwards direction and then this downwards direction. Right? You could tell from the equation which you're going to have because of the A term, leading coefficient. If the leading coefficient is positive, you'll have this orientation. If it's negative, you'll have this orientation. Right? Okay. Some points of interest. So if you were a tourist in math land, you would want to visit the vertex. And here's the vertex in this case. Okay. Also, you may wish to visit the axis of symmetry. Okay. So these guys are mirror images of themselves around that axis of symmetry. And usually the vertex is going to be given the coordinate h comma k. So this will have coordinate h comma k. And then the axis of symmetry, because it's located at this x position h, you'll have the formula x equals h for the axis of symmetry. Okay, okay, that's that stuff. We have a couple forms for these equations, just like with the equation of the line. You've got like 3 forms for it. Now you have a couple forms for the quadratic. So the first, the standard form, and sometimes it's called the vertex form because you could read the vertex right off of this form. Okay. So you see, if you get it into this form, the vertex will be h comma k. Vertex h comma k. All right, so let's look at graphing. We want to spend some time graphing this as a basic rule or protocol or strategy to follow. The first step is to look at that vertex, okay? In particular, you'll see if it's greater than 0 or is a less than 0. Jeez. Right? If a is greater than 0, then you have this shape. So we'll symbolize that statement by saying if a is greater than 0, then happy face. If a is less than 0, then sad face. Okay? Okay, so that's your first step. And from that, you get a pretty good picture of what the thing is. And then on top of that, once you get to the vertex, you have an even better idea. Okay, so you can just read the vertex off of the formula, and there you have it. Part 3, you want to get the x and y intercepts. Okay, so for the x-intercept, let y equal 0. For the y-intercept, let x equal 0. Fourthly, get the domain and range. And then fifthly, get your axis of symmetry. Okay. It's probably better to put step 5, like right here, along with step 4, because once you get the vertex, you'll be able to know, once you get the vertex and the orientation, you totally tell what the domain and range and the axis of symmetry are. Okay, so usually I'll do that immediately and then save the fun algebra for the intercepts last. Okay. So let's try it. Here's number 20. f of x is equal to x minus 3 squared plus 2. So first off, get your a value. A in this case is 1. It's greater than 0. That tells me the shape. It's like this. The domain will always be all real numbers. It's a polynomial type. Domains for there's no division symbol, there's no radical. Anything goes. The domain is all real numbers. The range you can tell from the y position of the vertex. So it's going to start here and then go up. So anyways, let's get the vertex. So you could read the vertex directly off of this. And it's kind of like this, you're going to move from 0, 0. If you think of it in terms of shifting, so you would have your common form, x squared right here. This would mean shift it over 3 to the right, 1, 2, 3. And then the 2 would mean shift it up 2, 1, 2. Okay, so you can remember, just pick off the 3 and the 2 for your vertex, or you can think of it in terms of shifting, which we spend a lot of time doing, so why not, So the vertex is at 3, 2. And I mean, that's the picture, really. We want more detail than that, but from this, you can read off the domain and range. The domain, negative infinity to infinity. The range, you start at 2 and then go up. Okay, so remember, the range you can think of as kind of like a trash compactor, and then where would the residue or the guts of the function be left over on the y-axis? Okay, and then it would be here. So the range would go from 2 to infinity. So you're literally borrowing the y-coordinate. Okay. And I have some colored pencils we could probably try using. Impossible to get out of the book case apparently. Okay, I got a couple that I'll have to do for now. Right, so the y-coordinate here, you're using it for the range there. Oh, don't look very good. Okay, so there's that. And then fourthly, we want the axis of symmetry. Okay? So we can figure that out again by using this y-coordinate, or sorry, no, if strike that, reverse it, you use the y-coordinate for your range, use the x-coordinate for your vertex, for your axis of symmetry. Okay, so that will go right here. So your axis of symmetry, we're going to say is x equals 3. The vertical line at x equals 3. That's really the hard stuff. The other stuff, in my opinion, algebra is easy, but it's mechanical. You should get to a point where you don't have to think very much about it. And in this case, we want the x-intercepts and y-intercepts. For the x-intercept, you let y equals 0. So you have 0 equals x minus 3 squared plus 2. So solve for x. So I'm going to subtract 2 to the other side. X minus 3 squared equals negative 2. And, there's a big problem there, right? You can't square anything and get a negative out. I mean, you could try to undo this, but you're going to get imaginary solutions. And we can't graph those in the xy plane. Okay? So there's no x-intercept here. Then for the y-intercept, you let x equals 0. So we'll have y equals 0 minus 3 squared plus 2. In other words, y equals negative 3 squared is 9, and then plus 2. 9 plus 2 is 11. Okay, so the y-intercept's at 11. And now we go and make our graph. So it looks like I need a lot of y. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Will be the y-intercept. Our vertex is at 3, 2. 1, 2, 3. 1, 2. The axis of symmetry is right there as well. So we'll have this looking creature. There, presto. Okay. 30, a little more work because we have to complete the square. Okay. So problem 30. Let's see what we have going on here. So we have f of x equals 2x squared minus 7x minus 4. it's not in our vertex form. The book wants you to do that. We're going to learn how to graph this more common form later, but we want to be able to convert it when necessary. So we'll rewrite it. Y equals, I'm going to have to factor out a 2 first. So 2 times x squared minus 7 halves x, and then we'll have to plus in something, and then immediately subtract that something, and then we still have the minus 4 to worry about. Okay. Okay. So the magic number we need to add in is negative 7 halves squared. So that'll be 49 fourths. Okay. Or oh, did I screw that up? So if I 2x squared minus 7 halves. So I made a mistake in my notes or something. B all over 2 squared. Sorry. So this, yeah. So that's wrong. It's negative 7 halves divided by 2 squared. So what is that? Well, that's negative 7 halves times 1/2 squared, which is negative 7 fourths squared. And that was my mistake. I forgot the 1/2. So the formula is always b all over 2 squared. I just put b in there and then squared it. Okay, so this would be at the end of the day 49/16, and I'm adding that here. And then when I subtract it away, it's not 49/16. You still have to compensate for this 2 that you'd factored out. So it would really be 49/8. You just multiply this times this and put that there. And then minus the 4. Let's go ahead and factor it now. So we have y equals 2 times x minus 7 fourths squared. And then I need a common denominator with these characters. So multiply top and bottom by 8. This thing will be 32/8. Okay. And then 49 plus 32, 19, 1, 4, 5, 6, 7, 81/8. So minus 81/8. Okay. And then we could read the vertex off, or if you'd rather, you can shift around to get to it. So this is a right shift by 7 fourths. That'll give you an x coordinate of 7 fourths. And this will mean move down 81/8. Okay, so we'll have negative 81/8 for that. You want to get probably a decimal approximation to make it easier to graph. This is 1.75. This is negative 10.125. Okay, so now once we have all this jazz established, we can go in and figure out what needs to be figured out. So firstly, we need the a value. A is 2, it's greater than 0, therefore you have a happy face. Secondly then, our vertex, 1.75 comma negative 10.125. Thirdly, then, the domain and range. The domain is always negative infinity to infinity. The range you can get from your vertex and kind of doing a quick graph. So maybe it looks something like this. Your vertex y coordinate tells you the beginning of your range. Okay, so it's going to go from here and then straight up. So it goes from negative 81/8. That's where you're starting. Okay. So negative 81/8, and then it's going to go straight up to infinity. Then finally, for your axis of symmetry, you borrow the x coordinate for that, and you'll have x equals 7 fourths if you're at 1.75. Okay. Once you get all that jazz, you can go ahead and graph the guy. So I'm going to need to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. and 1, 2, 3 over here. Whoops, I need the x and y intercepts, so I have to get those as well. So I'll hold off on all this. Right, so let's go ahead and get the vertex, right? So 1.75 and then negative 10.125 is about right here. The axis of symmetry is going right down through that. And I need the x and y intercepts as well. Okay, so for the x-intercept, you let y equal 0. And what do you get? You get 0 equals 2 times x minus 7/4 squared minus 81/8. And then solve for that thing. So add the 81/8 to the other side. Equals 2 times x minus 7/4 squared. Divide both sides by 2, which is equivalent to multiplying both sides by 1/2. And you get 81/16 equals x minus 7/4 squared. Do square root property, so you get x minus 7/4 equals plus or minus square root of 81/16, which is plus or minus 9/4. So x will equal 7/4 plus or minus 9/4. And then we can simplify that. So 7 plus 9 will give you 16/4, which will be 4. 7 minus 9 will give you negative 2/4, in other words, negative 1/2. Okay. For the y-intercept then, for the y-intercept you let x equal 0. So y equals 2 times 0 minus 7/4 squared minus 81/8. Okay. So y will equal negative 7/4 squared is 49/16 minus 81/8. 2 times this, the 2 will go, 2 goes in the 2 1 time, and then 2 goes in the 16 8 times. So you get 49/8 minus 81/8. So 81 minus 49, 7, 9, 10, 11, 2, 32, negative 32/8, which is negative 4 for your y-intercept. Sorry, I went off the page there. Okay, so we got all our information. We'll start plotting this stuff. So the y-intercept at negative 4, 1, 2, 3, 4. The x-intercepts, what are we determined? 4 and negative 1/2, 1, 2, 3, 4, and negative 1/2. And then just connect your dots, and it should make sense, right? If you get sort of a random point, like maybe way over here or something, you did something wrong, you need to go back and change it. Okay, so you need to think of this process kind of like an unpacking. Here you have this small seed, and then via algebra and everything we're doing, it unpacks itself into this information which we put in the XY plane. It's a very, very powerful thing. You know, you have this one line which gives you all of this. Okay? It's like making something from just this. This, you know, there's a lot of information in there. This math is like that. Okay, so that was a lot of work. Let's go to the next form, the standard form we're used to, the ax squared plus bx plus c. The problem with this form is the vertex is not there. You know, you need a vertex to graph it, and it becomes more work in this case. So first off, again, we're talking about graphing. And you look at that a term, and that'll tell you the same thing as it told you before. If it's less than 0, you're unhappy. If it's greater than 0, you're happy. Then you'll get the vertex, and this is where it's a little more work. You can't just read it off of the formula. So it'd be negative b all over 2a, and then you plop this into the quadratic and evaluate it, and it gives you your y coordinate. Okay? It's basically just, filling out a t-table with your x equaling this, and then you plug that into your formula and you get your y coordinate. Once you get that, then of course we need the domain, the range, and the axis of symmetry. I just put all those together. And then fourthly, get your x and y intercepts. And you should be good to go. Okay, so let's try it. Look at number 28. All right. So what do we have? We have f of x equaling x squared minus 2x minus 15. Right, so first off, the a value is 1, so that tells me it's a happy face. Secondly, let's get the x and y coordinates of our vertex. So the x coordinate, we should call h, is negative b. Okay, so negative 2 all over 2 times a. Negative 2 is positive 2. 2 times 1 is 2, so we get 1 as our x coordinate. And then the corresponding y coordinate, you just plug 1 into the formula. So you get 1 minus 2 minus 15. So negative 1 minus 15 is negative 16. Okay, from there then, the domain and range and all that stuff is easy. The domain is negative infinity to infinity. The range, you're borrowing the y coordinate. Okay. So that'll go from negative 16 to infinity. So if you look at the picture, it starts down and then it goes all the way up. And then the axis of symmetry from the x coordinate, x equals 1. Okay. Then the x and y intercepts. So firstly, the x-intercept, you let y equal 0, so x squared minus 2x minus 15 is 0. Typically, you don't want to use the quadratic if you don't have to. In other words, try the factor at first. So you have x minus 3 times x plus, or x plus 3 times x minus 5, 0. So x is negative 3 and x is 5. And then the y-intercept. This is always easy in this form because it turns out to just be this last number, negative 15. This will be 0, this will be 0 when you plug in 0. So what did I say? Y equals 0 minus 0 minus 15. In other words, y is negative 15 for your y-intercept. And that's all the info you need. So you think we unpacked it. Now we need to graph it. And I need a lot of tick marks on that y-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's our y-intercept. And then x-intercepts 1, 2, 3. And then 1, 2, 3, 4, 5. And then the vertex, what do we have? 1, negative 16. So that'll be right here. And then, of course, the axis of symmetry goes through that. And then you can draw your graph. Okay. Okay. We'll be looking at applications here. So in particular, with these kind of graphs, you have a top and a bottom, right? So when it's in this orientation, you have a minimum, okay, the bottom of the valley. When it's in this orientation, you have a maximum, okay? So our applications will be about mins and maxes, and let's take a look. So section 3, applications. So first off, if a is greater than 0, then f will have a min at x equals h, the x coordinate of the vertex, and the min is f of h. Okay. Then secondly, if a is less than 0, then you'll say f has a max at the x coordinate h, and the max is the f of that x coordinate. Okay. So you have to be able to differentiate between the position and the actual value of the max. Where does it happen and what is it? Okay, okay, so let's look at number 58. And we're talking about, well, I'm not sure what we're talking about. I'm going to look it up in a second, but they give you a formula. G of x equals negative 0.04x squared plus 2.1x plus 6.1. And in a second, I'll tell you the stuff. G of x represents a height in feet, and x represents a horizontal distance. So I think we're talking about a shot put player. Okay. In particular, it says when the shot whose path is shown, and they give you a picture, and the red graph is released at an angle of 65 degrees, its height, g of x in feet, can be modeled by this thing right here. Part A, what is the maximum height to the nearest tenth of a foot of the shot, and how far from the point of release does this occur? So they want to know what is the value of the maximum and where does it occur. So part A, note that this is a negative, so it does mean that we have a maximum. Okay, so the maximum h, the location of the maximum will be negative b, which is 2.1 all over 2 times a, so negative 0.04. Okay. That value then, which I have written down somewhere, is 26.25 feet, is where the max height will occur in the throw. What is the max height then? So the k value will just be g of this, so negative 0.04 times 26.25 squared plus 2.1 times 26.25 squared, just 26.25, and then plus 6.1. And if you plug that into your calculator, you get 33.6625-ish. Off the page there. So you want to write this up. If it's an application, and write up your answer. So we'll say the shot reaches its max height 26.25 feet away from the thrower. The max height then is 33.6625 feet. Okay. Okay. Some follow-up questions. What is the shot's maximum horizontal distance to the nearest foot, or in other words, the distance of the throw? Okay. So to figure this out, you just want to find where the height is 0, because that's where it hits the ground. Okay? So there'll be two solutions. One, behind the thrower, so it's not a real solution, but it's. I mean, don't misunderstand that as it's imaginary. No, it's just. It doesn't make any sense in terms of what's going on. It's. So in other words, when you're looking at the model of this thing, we're going to take this guy and set it equal to 0, right? So 0 is negative 0.04. So this is for part B. X squared plus 2.1 x plus 6.1. It's going to give us two answers. And one answer is the answer we want, which is this position here, when the height is 0. But there's technically another solution over here. But we don't consider that because that's, I don't know what that would represent. This is where the person's standing, throws the shot, lands here. This is just an extension of the model. Okay? And it doesn't really make sense. So we want this guy, this answer, not this guy. This answer will be negative. Okay, so what do? We're going to have to probably go to the quadratic formula, sadly enough. You can clean it up a little by multiplying through by whatever appropriate value, 100, we'll say a negative 100. So multiply through, that'll give you 4x squared plus 210x minus 210x minus 610. And then you can divide through by 2. So you get 2x squared minus 105x minus 305. And then I'll go to my quadratic. So x equals negative 105. Move that up. Plus or minus the square root b squared, negative 105 squared, minus 4 times a times c, all over 2a. I just put that into my calculator and evaluated it. I don't want to get too carried away with doing it by hand. And I got 55.26 feet for where it ends up. That's my positive answer. It was a negative 1, 2, and I don't include it. Okay, part C then, the last question. From what height was the shot released? Okay, so what is the initial height? You can tell that by finding where, if you look at the graph, where is, what's the y value when x is 0? Okay, so at this position where the person's standing, the x coordinate is definitely going to be 0. And then the y coordinate will be the height of the throw, the initial height. Okay, so what do you do? Well, you're going to plug 0 in for x and figure out what y is. So that's kind of easy. Y will equal 0 plus 0 plus 6.1. And that should make reasonable sense, 6.1 feet for the height of the, you can imagine if the person's 5'8", maybe the arm is over the head. So initial height is 6.1 feet. Okay. So always write up your answer for me on your applications, and that'll be it.